and gentlemen. This is Measuring Matter and correlates to Chapter 3.3 in your textbook. Your key concepts for this video are: what is the difference between mass and weight? What units are used to express mass and volume? And how is density determined? So first off, mass versus weight. In English, we tend to use mass and weight interchangeably, but in science, they actually mean different things. Mass is the amount of matter in an object, so how much stuff makes it up, whereas weight is the measure of force of gravity on an object. So your weight can change depending on gravity, but your mass will not. For example, if I'm here on Earth, my mass is about 70 kilograms, so my weight is 687 newtons. If I were to teleport to the moon, my mass stays the same, but I would weigh less because the moon is smaller and has less gravity. If I then teleport to Jupiter, my mass would still be the same, still that 70 kilograms that it was on Earth, but my weight would be more because Jupiter is much more massive and it has a lot more gravity pulling on my 70 kilograms. Now, I was just talking about kilograms and newtons, so quick review of scientific measurements. Here in the U.S., we use U.S. customary, meaning like pounds, feet, gallons. We do not use this in science. In science, we have a thing called the International System of Units. This is a standardized measurement system that was created by scientists worldwide, and it's a way for us to use measurements that are the same between countries so we can compare our results, which is really important for science. So when using science, International System of Units. Now, you might think the metric system is the same as the SI system. It's not. There's a lot of similarities. But in most cases, using the metric system is okay in science as well. But no pounds, no feet, no gallons, no U.S. customary. So now that we know what we measure it in, let's talk about how we express mass. Mass, as we know, is measured in kilograms. Kilograms is its SI unit. There are a couple different tools we could use to measure it. We could use a scale. We could use a triple beam balance or a TBB. We could also use an electronic balance. This does the same thing as a TBB, but it does it with electricity to measure the mass of the object. Now, one key thing, mass has a different base unit. A base unit meaning something with no prefix. So the base unit of mass is grams, because kilo, as we know from 6th and 7th grade, is a prefix meaning 1,000. So there are 1,000 grams in a kilogram, but the base unit is grams. Mass is the only one that has this difference. So let's talk about expressing volume. As we talked about in our properties video, volume has two types. We've got solid volume, which our SI unit is the cubic meter, or m to the power of 3, that's its symbol. And we measure this by length times width times height. Or we've got liquid volume, which its SI unit is liters. You actually already are used to liters because you buy soda in 2-liter bottles. Now, to measure volume for liquids, we can use a beaker. We can use a flask. Now these flasks, we've got two different types, and there's actually more than this, but both of these are a volume measurement. We've also got our handy-dandy graduated cylinders. So all of these tools can be used to measure liquid volume. So now that we know about mass and volume, let's talk about density. You know a little bit about density from 6th grade. You know that ice is less dense than water. That's why ice floats. But density itself is the amount of material in a given volume. So that ice, when it freezes, expands out. So there's less atoms in a certain amount of space, which makes it float to the top. And you can actually do a lot of really cool things with density. This is a density column. Each of these liquids, honey, corn syrup, maple syrup, milk, dish soap, etc., these have different densities, which is why they're layered like this. And we can drop actually real things in them, and those things will sink down to whatever level they match with the density. For example, this popcorn kernel here. It has a density that is less than corn syrup, so it floats on top of the corn syrup, but more than the maple syrup, so it sinks under the maple syrup. So that's how dense the popcorn kernel is. Whereas the cherry tomato is less dense than that. It floats on top of the milk, so cherry tomatoes are less dense than milk, but more dense than dish soap, because they sit in that dish soap layer. How do we calculate density? The equation for density is simply mass over volume. Now there's a handy way to remember this. If you draw a heart, and you draw a line through it. The top part looks like an M for mass, and the bottom part looks like a V for volume. So if you want a saying with this, if you're dense in love, you're going to have a broken heart. So if you don't pay attention to your significant other, they're going to dump you and you'll have a broken heart. So you've got that heart, draw a line through it, mass divided by volume. That's it. Make sure your notes hit all the key concepts and vocabulary, and if you wish to, try this challenge question.